In this video, I'll discuss alternate looping constructs. Loops are used to repeat blocks of code as long as a certain condition is true. Once the condition is false, the loop terminates and program execution moves on. There are several types of loops. While loops repeat the code block as long as or while a condition is true. A for loop repeats a predefined number of times. One variation of the for loop, the enhanced loop, repeats a block of code for each element of an array. Do while loops execute one time and then repeat as long as the condition is true. A common requirement in computer programs is to repeat one or many statements, to loop. Typically, the code continues to repeat the statements until something changes. Then the code breaks out of the loop and continues with the next statement. This pseudocode example shows a while loop that loops until the Boolean "are we there yet" is true. The first line establishes the while loop, the condition being not "are we there yet," not indicated by the exclamation point. So as long as we're not there yet, the three lines inside the braces will keep repeating. Read book, argue with sibling, ask "are we there yet?" and keep doing it until we're there. Being there means that the condition is now true, so the condition not "are we there yet" is no longer met and the while loop is broken. The program continues and the lines woohoo and get out of car are processed. This code demonstrates a simple while loop in a class called elevator. The elevator accepts commands for going up or down only one floor at a time. So to move a number of floors, the go up or go down methods on lines 7 and 9 need to be called a certain number of times. The go up and go down methods increment or decrement the variable called current floor, which starts at 1 on line 2. The Boolean expression returns true if current floor isn't equal to target floor, tested in the while loop beginning on line 5. When these two variables are equal, this expression returns false because the elevator is now at the desired floor, and the body of the while loop isn't executed. The while loop first evaluates a Boolean expression, and while that value is true, it repeats the code block. To avoid an infinite loop, you need to be sure that something will cause the Boolean expression to return false eventually. This is frequently handled by some logic in the code block itself. If you don't have a properly established testing condition, for example, if the expression somehow never reaches its necessary value, true, false, or some pre-established counter value, you'll have an endless loop and that will cause your program to hang. So it's very important to ensure that your programming logic will meet the condition needed to end a while loop. Loops are often used to repeat a set of commands a specific number of times. You can do this by declaring and initializing a counter, usually of type int, incrementing that variable inside the loop, and checking whether the counter has reached a specific value in the while Boolean expression. Although this works, the standard for loop is ideal for this purpose, and as I've already stated, an incorrect logic condition can cause while loops to hang the application if the counter never reaches its expected value. The three essential elements of a standard for loop are the counter, the Boolean expression, and the increment. All of these are expressed inside the parentheses following the keyword for, as seen on line 1 of the example. First, a counter is declared and initialized as the first parameter of the for loop, int I equals 1. A Boolean expression is the second parameter and determines the number of loop iterations, I less than 5. The counter increment is the third parameter, I++, and this will continue to add 1 to I until the value established in the second parameter, in this case 4 because it's less than 5, is reached. Keep in mind that you don't have to count by ones. You can increment the counter in any way you choose, so you can increment by 2, by 5, by 100, and so on, depending on your needs. For example, if you count up to 100 by 2s, then the loop will execute 50 times. The code block shown on line 2 is executed in each iteration of the loop. At the end of the code block, the counter is incremented by the amount indicated in the third parameter, in this case 1. As you can see in the output shown below the code, the loop iterates 4 times. This is a comparison of the while loop and for loop. For the while loop, the counter, I, is declared and initialized outside the loop on line 1. The counter is incremented in the while loop on line 4. The Boolean expression that determines the number of loop iterations is within the parentheses for the while loop on line 2. On the bottom, we can see the same logic implemented using a for loop. The three essential elements of a while loop are also present in the for loop, but in different places. In the for loop, all three elements occur within the parentheses on line 1, and the output for each of these examples will be the same. Keep in mind that the incrementing of I on line 4 of the while loop is absolutely critical if you're going to use a while loop in this way, because if you don't increment that counter, the while loop will never terminate and hang the application. This slide compares the standard for loop to the enhanced for loop. The examples here show each type of for loop used to iterate through an array. Enhanced for loops are used only to process arrays, but standard for loops can be used in many ways. The enhanced for loop uses a string variable, name, declaring it to hold each element of the array. Following the colon, the variable called names is a reference to the array to be processed. The code block is executed as many times as there are elements in the array. The standard for loop example uses a counter, IDX, which is declared and initialized to 0. A Boolean expression compares IDX with the length of the names array. If IDX is less than names.length, the code block is executed. IDX is incremented by 1 at the end of each code block. Note that inside the code block, IDX is used as the array index as demonstrated on line 2. The output for each example will be the same. The do while loop is a slight variation of the while loop. This example demonstrates a do while loop that determines the factorial value of a number called target. The factorial value is the product of an integer multiplied by each positive integer smaller than itself. For example, if the target parameter is 5, this method multiplies 1 times 5 times 4 times 3 times 2 times 1, resulting in a factorial value of 120. Do while loops aren't as common as while loops, and the decision to use a do while loop instead of a while loop usually relates to code readability. In a do while loop, the condition, shown at the bottom of the loop, is evaluated after the code block has already been executed once. If the condition evaluates to true, the code block is repeated continually until the condition returns false. The body of the loop, therefore, is processed at least once. If you want the statement or statements in the body to be processed at least once, use a do while loop instead of a while or for loop. So let's compare loop constructs, because there are times when you'll want to use each. First, the while loop is used to iterate indefinitely through statements and to perform the statements 0 or more times. The standard for loop is used to step through statements a predefined number of times. We use the enhanced for loop to iterate through the elements of an array or array list. And it's appropriate to use the do while loop to iterate indefinitely through statements and to perform the statements 1 or more times. There are two words that can be used to interrupt the iterations of any loop. First, break causes a loop to exit, or any block of code to exit. This can be used to exit a method, an if construct, a switch construct, or a loop. The break keyword will exit the containing code block, whatever that may be. Continue, on the other hand, causes a loop to skip its current iteration and move on to the next iteration. Continue is used only within a loop, and it's demonstrated here. The for loop iterates through the elements of the names array, but if it encounters an element value of unavailable, tested here inside the loop on line 2, it won't print out that value, but instead skip to the next array element using the continue keyword on line 3. In other words, the loop will skip line 4 every time it comes across the value unavailable.